Hi, this is Akash. I am studying in Veltech Malitech, Dr. R. Rangarajan and Dr. Sagundra Engineering College. And we are from a Department of Computer Science and Engineering. And this is our project work. The students representing this project who are M. Samasundram, S. Srinivasan, and S. Akash. Our project guide is Dr. V. Patsarthi, ME PhD, Dean of our college. So we are here to present the project named Tackling Information Fiddlers using clustering in high density RAM. So the overflow is the abstract and existing system disadvantages, proposed systems, advantages, literature survey requirements, architecture design, and data flow design and module list references. So first we are going to see the abstract. So the main concept of our project is to there is a more resource scarcity in our present state. So the resources so less in way. So the users are getting increases and the resources is getting scarcity. And the existing system, is IEEE 802.22 is the standard for wireless region area network. So we are hearing to study the concept of WRAN, and we are having existing systems which recommends the collaborative spectrum sensing to avoid the unreliability of the individual spectrum sensing while detecting the primary signals. But it opens an opportunity for the attackers and exploit the decision making process by sending the false reports. This problem is commonly known as a spectrum sensing data falsification attack or a Byzantine attack. Basically, in the existing system, the hackers are getting free from the protocols and they get easily escape from the system. And on our proposed systems, we can control the Byzantine attack by using strengthening the decision making algorithm of the base station. So the base station is the only thing which can sense the reports and it cannot find the fiddlers. So we are using the sensing capability to clustering the nodes and finding the fiddlers. So the complexity of the proposed adaptive reputation based clustering algorithm is low. So the complexity is less in our proposed systems and which is compared to the existing system. The proposed system deals with both independent and collaborative attacks since the defense mechanism is applied to a decision making a strategy of the base station. The error rate of the proposed system is reduced to the best because the algorithm uses several iterations based on the reputation before taking the final decisions. The advantages, actually we are seeing more and more advantages in the proposed system itself. So these are some of the common patterns which we are going to see here. There's no need of attackers identifier or history because the input of the algorithm is only a spectrum reports. The usability of the spectrum is reasonably improved when compared to the existing system. Also, the status of primary users is accurately detected by simple automated entry and exit notification so that the channel availability for the primary users is certain. The status of the network is tracked and this information will be useful for speeding up the algorithm. So we are having a literature survey. These are the papers we are just see before what we can do in this project and the software requirements. So in the software requirements we use NetBeans 8.0 and Eclipse Juno. For the database server we use SQLite and database IDE is SQLite browser. So hardware requirements, here we are having a developing kit with a processor, RAM and displays. So for the Eclipse Juno and the NetBeans 8.0 we have the minimum processor of 800 MHz Intel Pentium 3 or equivalent. And required is the Intel Core i5 or equivalent, and the RAM is minimum of 512 MB and the required is 2 GB of 32-bit operating system and 4 GB of 64-bit, and this space is 150 MB of free space of, and the required thing is 1.5 GB of free space. So and the level in the database is same as the Eclipse Juno is required. And further we are going to see the proposed architecture. So the primary users uses this base station by sending uninterruptible spectrum availability and provides the uninterruptible channel availability to the primary users, and the secondary users uses spectrum when it is only free, performs efficient decision making algorithm to identify the false spectrum reports, and the attacker sends false report to reduce the spectrum usability, and then only. So this box which represents the base station working. So first, when the primary user sends the uninterruptible spectrum availability, it just say whether it's available or not. Then only the secondary users can send this use the spectrum and it is free. So in that stage only the base station performs efficient decision making algorithm to identify the false spectrum reports, and then only it allocates spectrum to the secondary users. The data flow diagram. So primary users use the spectrums, and then the secondary user sends spectrum reports, and the attacker sends a false spectrum reports. This is the basic concept of a project. So where the attackers is only sending the false report, and then which we can see what's the data flow diagram of the base station will give the content. So it is used the spectrum report and performs ARC. ARC is adaptive reputation of clustering algorithm, and then the takes a decision and allocates spectrum for the secondary users. So this is the data flow of the base station working. And yeah, actually we already speak about the base stations working. So the base station does not have any informations about the attacking strategies or a number of attackers. So only information available to the base station is sensing reports sent by the users that are attached to it. Next, we are going to see about the algorithm what we can use in this project. So we design an adaptive reputation based clustering algorithm to defend against both independent and collaborative attacks. So the collaborative attacks is here is a Byzantine attack, and the independent attacks actually in the existing system that can only defend against the independent attacks. So there is one of the disadvantages. The main thing is they can't defend against the collaborative attacks. So the ARC nullify their influences on the final decisions only. See, there's the modules. We're having 5 modules here: determining the channel status, primary user implementation, spectrum sensing, and implementing ARC, responding to the secondary users. So this is our working place, and we use the NetBeans to enter the codings and do a blah blah things in it. These are the UI which we can get from the Android phone. So these are the references, and thank you.